Hello class, and we are now starting into our first lesson in geometry. Now, geometry is a very mathematical language. You've got to be very, very precise in what we talk about, and there are going to be a lot of definitions. Okay, so we need to have somewhere to start. We're going to start with point, line, and plane. Everybody should know what a point, a line, and a plane is. You've dealt with these before. So real quickly, I want you to pause the video and think to yourself, what is the definition of a point, a line, and a plane? All right, so let's see. Let's start with point. If you said that a point is a dot, you are technically incorrect. A point is not a dot. A lot of times we will use a dot to represent a point, to draw the point, but that's not what a point is. Just like the words Mr. Barnett is something that represents me, it's not me. All right, it's just some words. The dot is just a dot. We're going to use it to represent a point, but it's not a point. Okay, now a point definition is actually a little bit tricky. Okay, because what a point is, it is a specific location in space. Okay, but what is space? Well, space is all of the points boundless in 3 dimensions. Okay, so that means if I take that definition and plug it into the definition of point, I have a point is a specific location in the set of all of the points boundless in 3 dimensions. So I'm defining a point as being one of the points. And you can't define something as itself, right? Because if a point is the location in space and I take the location in space and plug it back into the point, I end up with a point is a location in the set of all of the locations in the set of all of the locations in the set of all of the locations. See, it doesn't work. Okay, and so let's move on. Let's look at line. Well, a line is the set of points that continues in 2 directions. It's all of the points that are in a straight line. So I'm defining a line as being all of the points that are in a line. And that doesn't work. Because again, I end up with all of the points that are in a straight, all of the points that are in the straight, all of the points that are in a straight. It's circling. We have the same issue with plane. So what these actually are, these are what we refer to as undefined. All right? Undefined terms is what we have here. And so that is no good. But we can't really define it, but we all know what it is, right? So we're just going to move on. A point. Let's talk about this. We're going to describe a point. We can't really define it, but we can describe it. A point is something that has no actual size. It represents an object or location in space. There's no actual size to a point. You can't measure it. There's no length, no width, no depth, nothing. It is a point. So, for example, I could use the tip of my pencil is very small, but it is bigger than a point. I could get smaller than that. The tip of a needle is even smaller, but still bigger than a point. The end of your hair is like one little hair is still bigger than a point. An atom has an infinite number of points on it. Okay, the electrons inside the atoms have an infinite number of points. That's how small a point is. It has no size. It can't be measured. All right. Now, the way we name it is with a capital letter. Always use a capital letter, and we will represent it as a dot with a letter beside it, usually. So this would be point A, and we just put A. Where's A? There's A. Point A. All right. A line. A line has no thickness, no width. It represents a continuous set of linear points. So you see how we're using line inside the definition of line. That's no good. It's a continuous set of linear points that extends indefinitely in both directions. So it's going to go forever that way and forever that way. And if it's going forever, can we draw it? No, we can't draw something that goes on forever. Our paper's not big enough, right? And besides that, it has no thickness. So no matter how skinny your pen is, it has thickness. You could measure it. 2 millimeters thick, 1 millimeter thick. It has thickness. It's not actually a line. We're just going to represent a line. A line can be named two ways, either with a lowercase italic or script letter or by any 2 points on the line. So for example, here we have line M, or I could say line AB or line BA, either way. And we use symbols. Geometry is a language of symbols. And so we put this little line up above the AB, and that shows that this is a line. Line AB, line BA. If I'm using the lowercase script letter, I have to have the word line in front of it. Do not put this little line above a lowercase letter like that. That's no good. Bad form. All right. So what about a plane? A plane has no thickness, no width, no depth. It is used to represent a flat surface that extends infinitely in all directions. So a good example of a plane would be like a piece of paper, right? It's very, very thin, but it's actually too thick to be a plane because a plane has no thickness at all. And if this paper went on in forever in all directions, that would be a plane, all right? Obviously, again, not going to try. The name that we use for a plane is a capital script letter. Line was a lowercase script. Plane is capital script. Or we can use any three non-collinear points in the plane. So, for example, here, generally when we're drawing a plane, we will use a parallelogram. We could have this capital Q right here. Notice it's italic, it's script. So I could call this plane Q, or I can just pick 3 points on the plane that are not in a line. So plane ABC. I could have just as easily called it plane BAC, plane CAB, doesn't matter. As long as you pick 3 points, there's not any order to them. They don't have to be alphabetical. Just 3 points that are not in a line. And very important that they are not in a line. All right? And the reason for that, so my paper here, if I have 3 points that are not in the line, my paper stays up, right? But if my 3 points are all in a line, so say I use the three points on my pencil and the paper falls down, it's no good. The points have to be not in a line. If they're in a line, well, you could be talking about this one or this one or this one. All of these, I could rotate it around like that, and all of those are on the line of my pencil. So they can't be in a line. Very important. All right. So now we've got 3 questions down here at the bottom. I would like you to pause the video, answer these 3 questions really quick. So we need 3 real-world situations that depict the concept of a point. It could be lots of different things. I just picked 3. Could be the tip of my pencil. It's not actually a point, but it could represent a point. It shows the concept of a point, a specific place right there. Could be a freckle. Could be a street address. That could be a point. If you're looking on a map, right, it drops a little pin on the map. That little point right there is the street address. 3 real-world situations for a line. Well, it could be a street. You know, if I'm using an address for a point, well, the street's kind of like a line. It goes on for a very long way. It's not really a line because it does stop, but it's kind of like a line. Up there, you see where the wall meets the ceiling. That's pretty much a line. Again, it's not really a line, but it could be characterized as a line. Or a yardstick, right? Very short line. 3 real-world things that characterize a plane: the surface of my desk, piece of paper I already showed you, the ground. These are just examples, right? There's lots of different things we could use. All right. So those were undefined terms, and we will use those things that we can't really define because they're circular, and to define things that we can actually define. So we already talked about this. The set of all the points boundless and 3-dimensional, that's space, right? That's everything. Okay, what about the set of points that are all on the same line, right? All the points on the same line, we call that collinear. Co means together, linear means line, so these are points that are together on the line. And just a little point, if you have 2 points, they are always collinear. It doesn't matter where those 2 points are, right? So if I have these 2 points, I can put a line there. If I have these 2 points, I can put a line there. These 2 points, line. What about these 2 points? Line. Doesn't matter where those 2 points are, you can put a line there. Now if you have 3 points, well, these 3 points are in a line. But what if I move this one over here? Well, now I can get 2 of them, but I can't get the 3rd one. All right, any 2 points are on a line, you got a 3rd one, you got to check it. Okay, what about if those 2 points do not line on the line? So I had these 3 points, right? not on a line. I can't draw a line for all three of them. What do you call them? If they are not collinear, we call them non-collinear. Non-collinear. So what if they're on the same plane? Well, if we said collinear was on the same line, then coplanar is on the same plane. And for this one, any 3 points will always be collinear. Doesn't matter where they are. If you've got 3 points, you can put a plane to connect them, right? 3 points will always connect with a plane. If you got that 4th point, stick 4th point out here, well, now my plane doesn't, I'd have to bend it, right? And that's not good. This is why a 3-legged stool will always be stable, but a 4-legged stool, it might wobble. It's because one of those points is not on the plane of the floor. And what do you call that 4th point that's not on the same plane? Well, that'd be non-coplanar. If it's not coplanar, it's non-coplanar. All right. Now, if you have 2 non-coplanar lines that do not intersect, so I've got these 2 lines. Notice right now they're coplanar, right? They're all on, I could put a piece of paper. What if I turn it like this? Right? They're non-coplanar, they don't intersect. Those are called skew lines. This would be like up there, I think it's hard to point to something like that. The ceiling and the wall meeting right there, and floorboard way over there. They're not going to intersect, but they're on in different planes. If they're on the same plane, they're parallel. These right here, parallel, right? Everybody's familiar with parallel lines. Okay, so we got a couple other things here. Where did my mouse go? There we go. Let's scroll this down. Intersections. We have 2 lines here. 2 lines will always intersect at a, right there, that is a point. What about 2 planes? If you have 2 pieces of paper, they intersect right here at a line. All right, think about that. When you open up your textbook or your notebook or whatever, those 2 pieces of paper, where they come together, it's a line. Right? And a line in a plane, so plane in my hand, line in my pencil, intersects right there at that point where they meet. So plane and a line intersect at a point. All right. So let's do some little questions here. How many lines could we draw through point A? Well, let's see. Give me a line tool. Okay, so point A, I could draw that one, or that one, or that one. Oop. That one. How many lines could we draw through point A? Well, I could actually draw a lot of lines there. I could draw infinitely many lines through point A. Okay, but what if I want to go through point B and also point C? Well, let's see. Let's see if I can do this. Point B and C, that is terrible. There we go. Goes through B and C. Could I draw another one that goes through B and C? No. I could draw one that goes through B. I could draw one that goes through C, but if it's going to go through B and C, it has to be this one, or it would curve, and if it curves, it's not a line. So only one, line BC, or we could also call it line CB. So we are going to put point D in the middle of this. It says in between B and C. Now, one real quick thing, between, the definition of between means it has to be collinear. So I couldn't put D out here, it's not in between them. So D is going to go right there, and I'm just going to the point D. And how many different ways could you name line BC other than calling it BC? Right? So we've got line BC. Could I call it line BDC? No. You only use 2 points. So I could, but I don't have to use line BC. I could call it line BD, or line CD, or line CB, or line DB. There are actually 6 different ways I could name this. All right? Think about it like this. If I talk about the road that goes from Comanche to Brownwood, I could say it's the Comanche to Brownwood Road. If I say it's the road that goes from Brownwood to Comanche, it's the same road, right? It doesn't matter. Right. So I could say it's the road that goes from Brownwood to Dublin. Same road. But that's what I would say. You're not going to say it's the road that goes from Brownwood to Comanche to Dublin. Well, I don't need to know that it goes to all three of them, so I know it goes to two of them, then I know it's going that same road. Okay, don't list all three. Okay, give 3 ways to name a line that connects these points. So I am going to go ahead and draw in that line, because why not? There we go. Line that connects all 3 points, all of the points. 3 ways to name it. So pause the video real quick and name this line in 3 different ways. All right. There are actually a lot of ways. We saw this one, there were 6 different ways here, right? So I just threw a couple on here. I could call it line EF. I could call it line EJ. I could call it line HF. I could call it line HG, GH, FJ, JF. Lots of different ways to name it, as long as you have only 2 points that are on this line. All right? That's it. Don't put 3. Put 3, it's wrong. Okay, so how many different lines can we draw through 3 non-collinear points if we take them 2 at a time? Okay, now obviously they're non-collinear. I can't draw one line that connects all 3, right? So how many lines could I draw to connect these if I'm just going 2 at a time? Well, let's see, to go from A to C, I can only do 1. From C to B, I can only do 1. From A to B, I can only do 1. Is there any other ways that I can connect these dots? No. That's the only way these points can be connected. So I just got those 3 lines. So down here, I would like you to pause the video one last time and name this line, and name this plane in as many different ways as possible. All right, so let's take a look at the line. There's a lot of names for that line, aren't there? Line RS, line RT, line RU, line ST, line TS, line, all of these different names. Or I could call it line D, right? I could say the road out here in front of the high school is the road that connects the high school and the square. It's the road that connects the high school and the library. It's the road that connects the library to Pizza Pro. Or I could just say it's Austin Avenue, right? Either way. For the plane, I could call it plane B, right there. Uppercase script letter, that is the name of the plane, plane B. Or I can just pick any 3 points that are on the plane as long as they are not in a line. All right, so for example, if I had point A right here, I would not use point X, A, and Z, because those are in a line. That would be no good. They cannot be in a line. Doesn't matter what order the points are, as long as you got them all. All right, and so there it is. Those are the first of our definitions for points, lines, and planes, and also some other stuff. So space, collinear, non-collinear, that kind of thing. Remember, points, lines, and planes are undefined. You can't have an actual definition for them, but we know what they are. Points get capital letters, lines get 2 capital letters or 1 lowercase letter. Planes get 3 capital letters or 1 capital script letter. For planes, you always have to have the word plane in front of them or it is wrong. All right. Hopefully you found that useful, and I'll see you in the next video.